Hello everyone, welcome to the lecture series 4 on the concept foundations of algebraic structures and number theory. So in this wonderful discussion we will talk more on rings and groups. So in the concept of groups and rings, in the previous discussion we were talking more on properties of rings and groups, and also we were discussing about the subgroups and subrings and its importance, its properties, and how it could be connected with application towards some real-time situations, like which are the very important areas, like how they are represented. These were the things we are discussing in the previous lectures. So we are moving further into groups and rings. In that, the next topic is quotient groups and quotient rings. So what is a quotient group and quotient ring, and how they are constructed? They are constructed by partitioning groups and rings into equivalence classes. So a very important topic, equivalence class. In school level, now after you discuss about sets, we discuss about relations and functions. In relations, again we talk about various relations like reflexive relation, symmetric relation, transitive relation. Furthermore, we talk about equivalence relation. So still more, when you come into groups and rings, we talk about equivalence classes. Okay, equivalence classes. So first of all, let me discuss about quotient groups. Quotient group is formed by dividing a group by a normal subgroup. Okay, dividing a group by a normal subgroup. The elements of the quotient group are the cosets. Already I told you, we can we can subdivide groups into subgroups, then again you can work on cosets. So here even in quotient groups we talk about cosets. The elements of the quotient groups are the cosets of the normal subgroup n, normal subgroup in the group. Okay, so and the group operation is defined on these cosets. Okay, that is the concept behind this. And also when I want to talk about quotient rings, I will similarly say that a quotient ring is formed by dividing a ring by an ideal. Ideal is another important topic. Okay, another very important topic. Maybe if we get an opportunity, we will talk more on ideals also. So here the elements of the quotient ring are the equivalent classes of the ring under the relation defined by the ideal. Okay, that is the very important idea behind quotient rings and quotient groups. So the fundamental theorems of group and ring theory, such as the isomorphism theorems and various such kind of theorems in groups and ring theory, provide powerful tools for understanding the structure of these algebraic objects. That is what we say, that is what we emphasize. We want to talk more on this, because these things, these kind of ideas, these kind of things and its examples and its applications towards industry, towards computer science, towards various new innovations, where these kind of small things, the quotient group, quotient ring, these kind of small ideas plays a very important role. Okay, very important role in building these structures, in the building the algebraic structures when it comes to programming, the coding areas in those structures. Fundamentally very important in I could say, like in maybe you can think about cryptography, or you can talk about machine learning, even more, where you can apply these algebraic structures and you can understand more on this. And going forward into this, we talk about applications of groups and rings. Applications of groups and rings. As I was telling you, it has a very important role in cryptography, because groups and rings have enormous applications across various fields. For example, let us take cryptography. Cryptography is an area where algebraic structures are essential in designing and analyzing cryptographic systems for like RSA and elliptic curve cryptography. Also I could say like more importance on cryptocurrencies, for example Bitcoin, in those areas. Okay, and coding theory. Groups and rings play a crucial role, a vital role in constructing and analyzing error correcting codes, which are vital for reliable data transmission. Okay, reliable data transmission. And also when you talk about quantum computing is the place where we talk a lot about recent innovations, where this group theory and its representation theories are fundamental in understanding the quantum mechanical systems and developing lots and lots of quantum algorithms. And physics, the other very important domain, where we talk about this symmetric groups and their representations, which plays a unique role, a vital role in describing physical phenomena. For example, from particle physics to general relativity, we can talk about lot of things here. So these applications highlights the practical importance, benefits of these algebraic structures in the modern innovative world of science and technology. So that is what I was eager to talk about here. So even you might be wondering when you start working more into this. Okay, so in this session I was trying to discuss something on some more things on groups and rings, and I was willing to talk about some applications towards this. Maybe in the further discussions we'll talk more on these ideas, and like even from your part you can think of this, you can browse more on the applications what I have listed here for your more and more of understanding towards the application towards your domain. Okay, thank you for listening. Thank you.